Hi viewers, welcome to a new video and you're watching Mechatronics Solution channel. And to this video we are going to learn about what is the Hall effect and the Hall sensor. Maybe you have watched the video or you have read the topic about the Hall effect, but I am not going to detailed study about the Hall effect. My main focus is on the Hall sensor. What is the Hall sensor? What's the application of Hall sensor? And what is the importance of the Hall sensor? And in my next video, I will show you how we can test Hall sensor if there is any problem occurred. But in today's video, we just only give the introductions, where we apply it, why we apply it, and the construction of this sensor. But before we talk about construction, I will give you little know-how about the Hall effect, because without knowing the basic of the Hall effect, we can't describe the Hall sensor. So I gave you little definition and little detail, 1 to 2 minutes. What is the Hall effect? I'm not going to drive the equation of the Hall effect, just give you little knowledge. You can easily understand the Hall effect sensor. So what is the Hall effect? The Hall effect is a phenomenon that occurs when a magnetic field is applied to the conductor or semiconductor carrying an electric current. So when the magnetic field is perpendicular to the flow of current, when current is flowing through a conductor, like this is a conductor and current is flowing, and we apply a perpendicular, this one is a perpendicular 90 angles, a magnetic field we have applied to this conductor. So what happened? It creates voltage difference. So very easy. When current is flowing the conductor, suppose this is a current, when current is passing through it, we apply this, suppose this is a magnetic field, we apply the magnetic field perpendicular to this conductor. So here create the across this material, what happened? Create potential difference. So across the potential difference is called Hall voltages. Across the material, mean this material, perpendicular on that voltages, these voltages, and voltage difference क्या होता है? The voltage difference are perpendicular to both the current and the magnetic field. Suppose I have made here one diagram figures, you can see easily. Suppose this is a conductor, a semiconductor or conductor. This strip, this rectangular is a conductor, and I have applied the DC volt to this conductor. What happened? Current I is passing through this conductor. Then I applied a magnet. I put a magnet perpendicular to this strip. So when this magnet is applied the perpendicular to this connector, so what happened here? Magnetic field, here produce magnetic field, and this magnetic field, what I have to do? This distract the flow of the particles. This particle is passing, and this magnetic field distract the particle which passing through this conductor. So what happened? The positive particles deposit on this side, and negative particle deposit on this side. When potential difference is occurred, so that potential difference is not too much, but we can measure it, and that potential difference is called Hall voltages. And in this way, these voltages are appeared here, and these voltages are perpendicular to both current passing through it and this magnetic field. Suppose on this direction, this is the x-axis, my current is flowing on this direction, and I apply the magnetic field B on the y directions. Then this voltages, this Hall voltages VH is perpendicular to in both current I and this magnetic field B. So this is the main theory behind this Hall effect sensor. So I just give you little idea. Suppose this one is my Hall sensor. Okay, so here is the, on the first pin we apply the positive voltages, battery positive voltage. On the second pin we apply the battery negative voltages, and the third pin we get the output voltages. Mean this is the Hall voltages. So how produce the Hall voltages? Here we put the magnet here of any type in any shape. We put this is our magnets. So when we apply the voltage, DC voltages, so when this magnet is detected here become we get the output voltages, and these output voltage used in our application. So now we'll talk about Hall sensor. What is the Hall sensor? Hall sensor is a crucial electronic device which converts the magnetic field into the electrical signals. So now, what is the application of the Hall sensors? The first application is automotives. So automotives mean we use this sensor in our heavy machineries, in our light vehicles, heavy vehicles, all the machineries, all the vehicles we use this Hall sensors. For example, we use it in the cars for the ignition system, and also we use for the detecting wheel speed, and also use in the position of the electric motors. Second use is industrial automation, where we use in industrial motor in robotic systems. We use in the robots to detect to control the position and speed of the robots. Third is consumer electronics, where we use in the field in the consumer electronics mean we use in the smartphones for the proximity sensing, and also for the magnetic switching, and also use in the smart watches. Fourth is electric vehicles. In advanced technology electric feature we also use in the electric vehicles as a current sensing, and also for the electric motor speed control. Fifth is medical devices. We also use in the medical devices, where we use for imaging and also for the monitoring the equipments. So now, what is the important? The first important is non-contact sensing. As we know, it's from its constructions and from its theory, we know that the Hall sensor detect the position of the magnetic field without physical touching, without physical contact. So they are not used to physical contact to anybody, to any things. Therefore it is very important, because if it's not touched to someone, it's reducing the tear and wears. Second one is a high reliability. So it is a very robust device. Therefore it is used in the harsh environments, means wherever is a very cold season or very hot seasons, we use this devices there. So therefore it's very reliable. Second is prescience. Its measurement is very accurate and very precise. Therefore, its use is very important. And last one is a low power consumption. Means it is a very energy efficient device. It needs to very low power to operate this device. Therefore, there are the importance of this sensors. Hope you like this video. Please don't forget subscribe my channel and share this video to your friends. So you have to like this video, then I will make more informative video for your people.